Hi everyone, this is a look at double replacement reactions. In contrast to our work on single replacement reactions, double replacement reactions only shows up in one style. Single replacements had two different styles. Double replacement sounds fancier because it's double compared to single, but they all work the same way. They all have two compounds reacting together, and the metals, or more specifically the cations, switch spots. Anytime we're going to make a compound, we have to think about the charges and balance them. And of course, we're always going to add coefficients to balance the reaction. Here's a few examples. First one has KBr, potassium bromide, reacting with HCl, hydrochloric acid. I notice that this is a compound reacting with a compound. It's double replacement reactions, but it's kind of nice. Just the two metals switch spots. The potassium is going to get together with the chlorine, and the hydrogen is going to get together with the bromine. It doesn't matter which chemical I think of first, as long as they're on the correct side of the arrow. So, to think about these compounds, I'm going to balance the charge. I might find myself going to the data booklet to look up a lot of stuff, or I might have it in my mind. Potassium is going to get together with chlorine. Potassium is 1 plus, chlorine 1 minus. 1 plus 1 minus, that's kind of nice. Just KCl. And now the hydrogen is going to get together with the bromine. Hydrogen 1 plus, bromine 1 minus. Again, 1 plus 1 minus. One of each, HBr. This first example, everything was 1 plus and 1 minus, so it does just turn out that this whole reaction is balanced. It's mostly to show that two metals, the two cations, exchange spots. I could have put HBr first and KCl after, the order doesn't matter, but I have now a balanced double replacement reaction. Second example, I have sodium hydroxide, NaOH, reacting with zinc nitrate. It's a compound reacting with a compound, it's a double replacement reaction. The sodium and the zinc are going to exchange spots. The metals switch. The sodium is going to get together with the nitrate. How are they going to get together? Balance the charges. Sodium is a 1 plus, NO3, nitrate, is a 1 minus. 1 plus 1 minus for the third time in a row. Gives us sodium nitrate. Now the zinc is going to get together with the hydroxide. Zinc is a 2 plus, and hydroxide, OH, a 1 minus. 2 plus, 1 minus. It takes two hydroxides to cancel off to balance the charge of one zinc atom. ZnOH in brackets, 2. Now we need to balance this reaction. Just going to work from left to right and double check. Here's one sodium, that's good. We move on. OH, over there it says OH2, that's 2. When I do that, I notice that now I have two sodiums, so let me do that. Now let's see what we have. Two sodiums, two OHs, two hydroxides. Over here, OH2. One zinc, two nitrates, and two nitrates. We have a balanced double replacement reaction. Finally, most of the time we're going to have sentences to work with. This one has iron 2 carbonate reacts with sodium sulfate. Iron 2 carbonate, it's iron in combination with carbonate. Let's think about the charge. Iron could be +2 or +3. This Roman numeral 2 lets me know that iron has a charge of 2 plus. Carbonate, when I look it up in the data booklet, has a charge of 2 minus. 2 plus, 2 minus, iron 2 carbonate. One of each, one iron, one carbonate, FeCO3. Reacts with, that's this plus, sodium sulfate. Sodium is 1 plus, sulfate 2 minus. 1 plus, 2 minus. Na2SO4. I notice that this is two compounds reacting together. It's double replacement. The iron and the sodium are going to switch spots. The iron, which is a 2 plus, is going to get together with the SO4, which is 2 minus. 2 plus, 2 minus gives us our iron 2 sulfate. Now, the sodium is going to get together with the carbonate. Sodium is a 1 plus, carbonate a 2 minus. So we end up with Na2CO3. Coincidentally, this does just happen to work out to be balanced. When we double check, one iron, one carbonate, one CO3 on either side, Na2, Na2, and one SO4, one sulfate on either side as well. When we have two compounds reacting together, the cations, the metals, exchange spots, and we have a double replacement reaction. Lots of thinking about charges. Because there's no individual elements anywhere in a double replacement reaction, diatomic elements are none of our concern. We just need to take it slow, especially if we're starting from a sentence. Don't be afraid to take your time to work that data booklet looking up charges. And I hope that helps.